Okay, finally got everything settled. Okay, so as I was saying, two things I want to do today. One, I've already passed back the quiz. We'll go ahead and talk about any questions you might have. And then after that, we will continue to solve quadratic equations today by completing the square. Okay, so let's see what we've got here. All right, here is the quiz. Was there anything on there we wanted to take a look at? Okay, Oliver. Number 5 and number 2. Okay, so let's go in order. We'll do number 2, and then we'll move on to number 5. Okay. All right, so give the axis of symmetry and vertex for -2 x minus 3 squared plus 4. Then graph it, state the domain and range in interval notation. Okay, now remember in vertex form, the vertex is going to be found at hk. Which one do I take the opposite of? It's always the h. Remember, because when you're talking about a horizontal shift, you take the opposite direction. So my vertex here is going to be a +3, +4. You always leave k as is. Now, when we're making our table, I'm going to go ahead and again put that vertex right in the middle. Okay. Now, if I have the vertex, remember that x value, that's my axis of symmetry. So I'm going to go ahead and say x equals 3. All right. Now, let's go ahead and turn our attention to the table. Just like we've done before, we're going to count up and down 3 by 1s. Okay. Let's see here. So this would be 4, 5, 6. This would be 2, 1, and then 0. Okay. And then all I want to do is go ahead and take the x's one at a time, substitute them in, and then just evaluate. So let's start with 0. So f of 0, that's going to equal -2 times. So we're going to plug it in here. X minus 3 becomes 0 minus 3 squared, and then plus 4. Okay, so let's see. 0 minus 3 is going to give me a -3. All right, so let's run through this. -3 squared. Okay, that's +9 times -2. -18 plus the 4, so that's going to be a -14. There we go. So -14. In fact, that is the y-intercept. Okay. And remember, I said it before, we're going to see the symmetry of the y values in the table. So if 0 yields a -14, 6 would also yield a -14. Remember, you only have to work half of the table. Let's do one more of these. Let's do 1. So f of 1 equals, so -2, x minus 3 squared becomes 1 minus 3 squared plus 4. Okay. So let's see, 1 minus 3 is a -2. Okay, -2 squared. 4 times -2. -8. There we go. Plus 4. Looks like I'm going to get a -4. Okay, so 1 and 5 would both yield the same y value. Okay, and then if you did the same thing for 2 and 4, okay, you're actually going to get 2 out of that. Okay, so any questions on how I filled in the table? Okay, well, let's see here. We have a vertex at 3, 4. Bless you. So here's my vertex right there. This is going to open down. Let's see. We have a 2, 2. Okay, we have a 4, 2. Okay, we got a 5, -4. And we have 1, -4.
Teachers of juniors, think N through Z. N through Z. Students, if you're a junior, N through Z, please proceed to the dining hall to complete your Stop the Bleed training. Make sure you have your ID badge with you. Thank you.
Okay. All right. So we're going to have a graph that looks something like that. Okay. Now remember, two questions when we're thinking about domain and range. Domain is how wide, the range is how tall. Now, whether the parabola is opening up or down, what's nice is the domain is always the same. How wide is it going to become? Oh yeah, Smart Pass isn't working, so just go ahead and grab the pass. So how wide are these parabolas going to get? Infinitely wide. So in interval notation, I would go ahead and say negative to positive infinity, or you could simply state all reals. I think there was only a handful of people who tried to do it with inequalities. Okay. Now the range, this is going to determine or be determined by whether your graph is opening up or down and where your vertex is. So because this is opening down, it goes infinitely far down. You were at the stop and bleed? Okay. Okay. Well, see, it goes all the way down to negative infinity, but how high does it go? Okay, what's the y value of my vertex? 4. Okay. Now, because it is part of the vertex, I'm going to cap that with a bracket. Okay. Or you could say, if you did the inequality, y less than or equal to 4. All right. Everybody, is that good? Okay. And we wanted number 5. Let's see, number 5. If the vertex of a parabola is hk and it opens downward, which of the following must be true? Well, we're talking about vertex form, right? So a times x minus h squared plus k, whether it's standard form or whether it's vertex form, what do we look at to determine if it's opening up or down? What's that? If what's negative? The a. Okay, so it doesn't matter, if h is negative or k is negative, so we can just go ahead and get rid of those. If it's positive, it opens up. If it's negative, less than 0, then it's going to open down. And that's the same for standard as it is for vertex form. Okay, so Oliver, is that good? Okay, was there anything else? Okay, like I said, overall, fantastic job. Okay, but if anybody did score below an 80 and you're looking to retake that, you have until, I believe I said on the posting, next Friday morning. So you got plenty of time. You'll just have to turn in the vertex assignment before you retake. Okay, so let's go ahead and put that to the side. If you will, go ahead and pull out the notes we had yesterday on completing the square. Okay, they're going to look just like this. I just kind of wanted to emphasize what we were talking about yesterday. These are the 3 strategies or methods we're going to use to solve a quadratic equation. Okay, factoring, which we've already spent quite a bit of time on, completing the square, and the quadratic formula. Okay, now you're welcome to use any of these that you like. Okay, but the only 2 that will work every single time is going to be completing the square and quadratic formula. Okay. That gets you the answer every single time. Unfortunately, not everything is factorable. So while factoring is great, it's great if it factors. Okay. All right. So one of the things we started out with yesterday was what's known as a perfect square trinomial. Can anybody remind me what that is? In your own words. Okay, sir. Okay, he's absolutely right. So what we're looking for here, a perfect square trinomial, is any trinomial that when I factor it, the 2 groups are identical. Just as we saw yesterday, x squared plus 14x plus 49. This was x plus 7 times x plus 7. Okay, that is what makes that a perfect square trinomial. If they're not identical, well, then it's not a perfect square trinomial. Now, by completing the square, this is what we're going to create. Okay, we're going to create a trinomial that looks just like that. Okay, so I don't believe we made it very far. Here were the steps in case you forgot those. You can go back and take a look. We'll just get into a problem. But this right here, b divided by 2 squared, that is actually what we refer to when we say completing the square. Okay, that's the most important part. Now, before we go ahead and move on with number 2, okay, let's revisit number 3 for just a second. Anybody remind? Oh, here we go.
Okay, seniors, last name A through M. Seniors, last name A through M. Please proceed to the dining hall. Make sure you have your ID badge with you or temporary so that you can complete your Stop the Bleed training. Seniors, last name A through M. Thank you.
Okay, so everybody's going to remember yesterday that when we solved number 3, we ended up with 4 and 14. Everybody's okay with that? Okay. Now, we solved it by completing the square, but I want to go ahead and really get you to start to see that it doesn't matter if it'll factor or quadratic formula, you're always going to get the same response. Let's think about these two numbers. Okay. What can I do with 4 and 14 to get 56? I can multiply them, right? 4 times 14 is 56. So what's 4 plus 14? 18. So see, I could have easily solved this one by factoring and said x minus 4 times x minus 14 is equal to 0. So that's the point that I'm trying to make. If you can solve a quadratic equation by factoring, you can solve the same equation by completing the square or the quadratic formula. You're going to get the same answer. Okay? I would still have to set these equal to 0 by the zero product property, but you're still going to get these right here. Okay. Is everybody okay with that? Okay. All right, I just want to go ahead and make you aware of that as we go into this. All right, let's take a look at number 4. Now, there's one thing about completing the square that I haven't mentioned yet, and this is super important. You can only complete the square if the leading coefficient A is a positive 1. Okay. If it's not 1, you're going to need to get rid of that coefficient. Okay. Now, what they're saying here in the instructions is to go ahead and divide through by whatever it is. So on number 4, where it says 2x squared minus 16x equals a negative 30, okay, we'd go ahead and divide through. I'm going to go ahead and show you to do something different, okay, because I think for those folks who are going to continue to move up in mathematics, this is going to be really useful to you. Now remember, when you're factoring, you always want to set it equal to 0, okay? If I'm going to complete the square, you want it equal to your constant. All right, so I'm going to go ahead. See how we have 2x squared minus 16x equals negative 30. So this one's all ready to go. Now, that 2 is a problem. Instead of dividing through by 2, we're going to pretend 2 is a greatest common factor. We're going to factor it out. Okay, so don't worry about the negative 30 right now. Just consider this binomial right here. Okay, and I know that x is also part of the GCF, but we're only needing to get rid of the coefficient. So let's say I pull out the 2. Okay, this is going to leave me x squared minus what? 8x. Now I'm going to go ahead and put plus, and I'm going to leave a little bit of room before I go ahead and say equals negative 30. Now, why would you think I'm going to leave a little bit of room there? Remember, what am I about to do? Blank the blank. Complete the square. We're going to complete the square. Okay. See, now that I have this coefficient of 1, this is the value of b that I need to complete the square with. Everybody follows? Okay. Remember, we're going to do 2 things to it. I'm going to take this negative 8, I'm going to divide it by 2, and I'm going to square it. That is what we call completing the square. Okay, so what is negative 8 divided by 2? That's a negative 4. I'm going to square that. What's that? 16. Okay. Now, I'm going to go ahead, remember, whatever you do to one side, you got to do to the other. So if I add 16 here, I'm going to add 32 here. Wait, what? What's up? Oh, yeah, right here. Okay. What did I do? Where did that 32 come from? See, you can't forget about that coefficient that we factored out. We're not adding 16, we're really adding 2 times 16. So that's something you're going to have to remember when you're working a problem like this. Okay, everybody with me? Now, because I completed the square, this trinomial right here, that's now a perfect square trinomial. Okay, what two numbers would multiply to give me 16, but also add to give me negative 8? Okay, wouldn't it be negative 4 and negative 4? Man, that's not... All right. So we've still got the 2, but this right here, that would be x minus 4 times x minus 4 equals, what's a negative 30 plus 32? 2. Okay. Now, instead of multiplying the group by itself, let's do like we did yesterday. Let's write it combined. So 2 times x minus 4 squared is equal to 2. See, this equation is already looking a lot better. Okay. Now, we want to go ahead and get that squared group isolated, so I'm going to go ahead, anything that I originally factored out, I'm going to go ahead and divide by. So what is x minus 4 quantity squared going to equal? Okay, 1. And we are very, very close to being done with this problem. Okay. But are there any questions about anything I've done so far? Okay. Anybody confused? Anybody not sure where something came from? Okay. Well, how do I get rid of the square? We got to do what? Oh, you folks are quiet today. We got to do what? Square root. Okay, so a square and a square root are going to cancel, so x minus 4 equals, well, the square root of 1 is 1. You're welcome. Okay, so what am I forgetting here after I take the square root? Okay, Scarlett? Positive and negative. When you're solving an equation and you take an even root, we're going to put plus and minus in front of it. Okay. So let's see here. I'm going to go ahead, separate this. So x minus 4 is going to equal a positive 1. X minus 4 is going to equal a negative 1. So in either case, when I add 4, 1 plus 4, my first solution is x equals 5. Okay. What about the other one? What's a negative 1 plus 4? Oh, 2, 3. There we go. So this is going to be 3, 5. Okay. There we go. That's completing the square. Okay. Now, if you like this method, you are welcome to use it. The only condition is that leading coefficient A has to be 1. Other than that, you're good to go. It'll work every single time. Now, this particular problem, what if I went back and solved it by factoring? What's going to happen? Would I get the same answers, or am I going to get different answers? I'm going to get the same. Would anybody like me to prove that to you? You trust me? Okay. All right. So let's try another one of these. All right. So number 5. So 4x squared minus 8x equals a negative 3. Okay. So they've already got the constant isolated. Okay. Now, I can't complete the square because something's in my way. What is it? The 4. It has to be a 1x squared. So this binomial on the left, let's factor out the 4. Remember, we're not taking the entire GCF. We're only removing the coefficient. So this is going to be 4 times, it would be x squared what? Minus 2x. then I'm going to put a plus and leave a little bit of room. Always going to leave a little bit of room there because that's where we complete the square. And this is going to equal, this will let me write that. Okay. Okie dokie. Equals -3. Okay. Once you got that coefficient of 1, this is the value of b that I'm going to divide by 2 and square. Okay. So let's see what I got here. So a -2 divided by 2 squared. Well, that's going to be a -1 squared. What's a -1 squared? That's a +1. So if I'm going to add 1 here, what am I adding on the right? 4. Remember, you've got to multiply that value by whatever it was that you factored out. Okay. Everybody okay where these values came from? Okay. What can I now call this trinomial that we just created? Starts with a P. That's a perfect square trinomial. Okay. So what two numbers will multiply to give me 1 but add to give me -2? So it'd be x minus 1 times x minus 1, right? So at this point, I don't think I need to write it down any further. Let's just go ahead and say that this right here, that's now x minus 1 squared. We got the 4 in front of that. And what's that going to equal? 1. -3 plus 4. Okay. Now just think about what we did on the previous problem. Oliver. Yeah, I don't think anybody's that right now. Don't worry about the smart pass. Just take the restroom pass and go. Okay. So what am I going to do next? What's my next step? We're going to divide by 4. Okay, divide by 4. So that's going to give me x minus 1 squared equals 1/4. Now that the squared group is all by itself, okay, what am I doing? Got to take the square root to get rid of that. Okay, so this is going to give me x minus 1 equals, what is the square root of 1/4? Remember, when we take the square root of a fraction, we take the square root of both the numerator and the denominator. So this would be 1/2. Can't help but feel, though, we're forgetting something. Plus and minus. Remember, we took an even root, so plus and minus. You see how these problems are starting to go a little faster now? We've gotten several that we could use as a template. We can go back and look at them, but we're already getting the idea. Okay, so let's see here. One solution will be x minus 1 equals a positive 1/2. The other one is going to be an x minus 1 equals a negative 1/2. Okay, well, let's, in either case, we have to add 1, right? Ah. Okay. So if I add 1, okay, we need a common denominator. So this would be 2/2. So what's 2/2 plus 1/2? 3/2. Now, if you wanted to write that as a decimal, I'm fine. 1.5 is equivalent. Okay. Now, for the other one, this has to be 1 minus 1/2. Okay, because when I add the 1 over, it becomes positive. So that's now 2/2. So what's that one? X equals 1/2. Okay. There we go. And remember, these aren't random numbers that we're finding. If I were to look at the graph of number 5, what do 1/2 and 3/2 mean? X-intercepts. It's where the graph is crossing the x-axis. All right, and I know this is going to get old and monotonous, but same problem. What if I went back to the beginning and I factored it? What's going to happen? You think I'm going to get the same or different answers? You're going to get the same. Anybody want me to show you on this one? No? We're confident? Okie dokie. All right. Okay. So you're probably thinking to yourself at this point, okay, I can do one on my own. Okay, I hear you. 3x squared plus 10x plus 8 equals 0. So I'm going to help get the ball rolling on this one. If you choose to complete the square, what's the one term you got to move over? The constant. You want the x squared and the x all by itself. Okay, so that's step one. 3x squared plus 10x, that's going to equal a negative 8. Everybody's okay? Can I complete the square? Okay. What's the problem? Remember, what's that rule? There you go. The only way you're allowed to complete the square is if that leading coefficient is a 1. Now, you're going to notice something here. Up until now, the problems have been pretty nice to us, right? But I'm still going to pretend 3 is a GCF, and I'm going to divide it out. So I'm going to go ahead and say 3, parentheses, x squared. Anybody think they know what I'm going to multiply that by to just get 10x? Remember, think about what we talked about when we first started talking about factoring. If you're not sure what has to go there, take what you need. What do I need? Okay, what do I need? I need a 10x, right? Divide it by what you're factoring out. So it's got to be 10/3 x. So some of these are unavoidably going to go fractional. That's okay, because we like fractions, right? Absolutely. Absolutely. We love them. But take a look. If I go ahead and multiply 3 times that 10/3, the 3's cancel. See, there's the 10 I'm looking for. Okay. Now, the fact that we have a fraction here changes nothing. I'm still going to go ahead and put plus, leave a little bit of room, and then this is equal to negative 8 plus whatever I have. Okay. So now I want you to take care of the next step for me. I want you to find what we're going to add to both sides. So this is what I'm talking about here. Up until now, there might have been some folks who were like, you know what, I really like completing the square. I'm going to use it every time. And you are absolutely okay to do that. Sometimes you're going to go fractional. Remember, if I were to solve this by factoring, I'm going to get the exact same answer. Okay. So maybe you want to latch onto a couple of ways just in case you run into something like that. Okay. How are we doing on time? Yeah, we're doing okay. Okay, is everybody about ready? Okay. Here's what we should have gotten. Okay. In this space right here, we should have gotten 25/9, but we're going to be adding 25/3 to the other side. Okay. How many folks got that? Okay, I don't see any hands. Let's talk about it. Okay. So this right here is the value of b, right? So that's what I'm going to divide by 2 and square it. So 10/3, I'm going to divide that by 2, and I'm going to square what I get. Okay. Well, make it easy on yourself. Let's pretend that this 2 right here is over 1. Let's make it a fraction. Because what's the rule? Okay. If you are dividing by a fraction, you what? Everybody's talking at once. I can't hear you. Okay. You multiply by its reciprocal. There we go. So inside, I'm going to have 10 thirds times 1/2 squared. Okay. Now, I can multiply and say 10 sixths, or I can simplify this. 2 and the 10, they become 1 and 5. Okay, so what I really have here is a 5/3 squared. Okay, so what's a 5/3 squared? Okay, which would be 25/9. See, that's where we got that 25/9 right there. Okay, but now I'm confused. Where did that 25/3 on the right come from? Remember, you've got to multiply by what you factored out. So if I put 3 times 25/9, okay, the 3/9 can simplify. Okay. Everybody okay? So you take it one step at a time, you're going to be fine. Don't let the fact that it's a fraction intimidate you. Okay? Fractions are our friends. They're going to help you. Okay. So let's go ahead and factor this. So 3. Okay. Now, if you're dealing with a fraction like this, it might be a little more difficult to figure out, okay, what am I going to multiply to give me 25/9, but then add to give me 10 thirds in the middle? Well, you might have noticed there's a shortcut so far. Okay. Whatever your symbol is right here, whether b is positive or negative, that's exactly what's going in your squared group. Okay. Now, on every other term, we've gone from an x squared to an x. How did I do that? I took a square root. Okay. Well, why don't I do the same thing here? What's the square root of 25/9? 5/3. Because let's think about this. Okay. What's 5/3 times 5/3? Well, that's a 25/9. What's a 5/3 plus a 5/3? That's a 10/3. See, everything is matching up. Okay? But this is the very reason why some students choose not to use completing the square. Okay, it works really well on some problems. If it goes fractional, it's not difficult, but you got to work through those ratios. Okay. Now over here, we still got to figure out what this is. So a -8/1 plus, okay, we have a 25/3. Well, we got to get a common denominator. Okay. So that would be a -24/3 plus 25/3. See, all I'm doing is combining what I have on the right. How many thirds do I have? Just one. So this equals 1/3. Now, we got fractions, but it still looks like the other problems. Okay, I can't emphasize that enough. Now, before I take the square root, I got to do what? I got to divide by 3. Okay, but because we have a fraction over there, you don't make it easy on yourself. Okay, dividing by 3 would be the same as multiplying by 1/3, right? Aren't those still going to cancel? Yeah. So why don't I just do the same thing on both sides? Okay, there's no reason to make your life more difficult. So this is going to give me x plus 5/3 squared is equal to 1/9. Okay. Now what? We're going to take the square root. Okay, so I'm going to have that x plus 5/3 is equal to, what's the square root of 1/9? 1/3 with a what? Plus a negative. Here we go. Now, how am I going to get the 5/3 to the other side? I'm going to subtract it, right? So would everybody agree that one answer would be a -5/3 plus 1/3? Another one would be a -5/3 minus 1/3. Okay. Well, let's say, what's a -5 plus 1? -4, so there's your first answer, -4/3. What about a negative 5 minus 1? That's a negative 6/3, which is what? Negative 2. There you go. Okay. We are at the very end, so we gotta wait. All right. So I'm kind of curious. This one, I mean, wasn't anything you haven't ever seen before. What really slowed us down was those fractions, right? Okay, but that's okay. Right? What would have happened if I'd solved this same problem by factoring? I would have gotten the exact same answer. Okay, so this is where you got to have to make a choice. What method is going to be best for me? Okay. All right. So good, 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 good. So I think I want to go ahead and show you at least one more problem. So tomorrow, not today, don't worry. So tomorrow when we come in, bring these notes back. I want to go ahead and work one more before we get on to quadratic formula. Okay. All right. Okay. Here we go.